Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. Okay, my name is Norazrena. Okay, I'm from the same faculty with you, of course, Faculty of Educational Sciences and Technology. And also I'm from the Educational Technology Department. Okay, so basically you can see from here, my slide is 85 slides. I have 85 slides, but I don't think we can finish in 1 hour. So I will go fast. Okay, so you can download from here. You can scan this QR. Please let me know if it happens that you cannot download. Do let me know. Okay, maybe later I can share the link to you. Okay, for those have downloaded, please let me know. Okay. So at least I know that it can be downloaded. Okay, anyone try download already? Done. Okay, Alhamdulillah. So it can be downloaded. All right, thank you very much. Okay, so for today's topic, okay, it's actually just quantitative data analysis, of course, using the SPSS, okay, the simplest way. Okay, this even SPSS is you can get it from software center from UTM. However, there is a limitation such as you need to use the VPN. Okay, or there is certain function that cannot be used in the SPSS with UTM license. All right, where to download? Here, please scan this QR code. Okay, wait for a while. Here's the point. Okay, this is the QR code. Cannot download. Some of you can. Maybe it some cannot. Okay, for those, maybe you have the link, you can share in the chat. Okay, or maybe we can do it later. All right, Ken? Okay, thank you. All right, so the title for today is Effective Strategies for Quantitative Data Analysis using SPSS. All right, so let's go. Okay, this is the simplified version. This is actually by the PhD student who helped us, the lecturer, to make it into very simple. This is not considered simple, but in one figure, you can see the possible statistical tests to be used. Okay, for the scientific method, of course, we can consider this research design. We have the qualitative, we have the quantitative, and then the mixed method. Okay, of course, you know the mixed method, right? Okay, so the combination of both is mixed method. Okay, but today I only focus on the quantitative method and specifically using the SPSS and very simple analysis, not too difficult to use. Okay, so when you are doing statistic and of course the statistical analysis, okay, you will have the interpretation, okay, in terms of descriptive and inferential statistic. We have two types of statistic, descriptive and inferential. Okay, those that related to central tendency and variability, including this, the mean, median, mode. I know that you heard about this, even if you don't understand, but you always heard about it. Okay, about them. So that's our central tendency, and the variability related to range, standard deviation, variance. So these are actually about the descriptive statistic. Just describe it. When you get the value from this, you describe it, that the descriptive statistics. So of course, if you are doing research, you want to explain in your chapter 4 or 5 related to results and findings, descriptive statistic is not enough. Okay, unless you are doing the simple survey, you will have only descriptive, the percentage and everything. Very simple. So it's actually not up to PhD standard. All right. So the inferential statistic is important. for the quantitative analysis. However, inferential statistic consists of either parametric tests and non-parametric tests. Okay, so we have the parametric and non-parametric. So I'll go further after this, all right? Okay, what you will learn is basically about the research design, of course, a little bit about research design, introduction to statistics, the normality test, the hypothesis testing, and then the statistical test, all right? So first one is the research design, okay? So these are in the research methodology, you learn about this, okay? In order to write the thesis, you need the research problem. You must have the research problem and then the literature review, research question. So, and then you choose the quantitative research or qualitative research or mix of them, okay? So there are categories related to quantitative design. For example, mixed, correlational, and survey. Okay, and the rest is about the combined and the qualitative. This is combined, also called combined, depends on the book, and this is by Creswell. Okay, so depends on the book. So this book use combined design, and it's in and then certain use mixed method design. Okay, so there is a few names for that. Okay, so and then in your thesis, you will have the sampling, instruments, data analysis, interpretation, and lastly, of course, the discussion and so on. All right, so this is basically your research. So for today, we only focus on quantitative design, especially experimental design. All right, so in the experimental research, okay, so experimental research aims to manipulate an independent variables and then examine the effect that this change has on a dependent variables. So basically, there are two types of variables, so independent and dependent. So the dependent depends, okay, on the independent. So we manipulate the independent. So we will see what is the effect towards the dependent variables. All right. And we also have the non-experimental research. Okay, researcher does not manipulate the independent variables. Okay, not to say that it is impossible, but either impractical or unethical. Okay, so it's not possible to identify the cause and effect. Okay, for example, it's about the drugs and so on. So it's not ethical to manipulate the independent variable, for example. Okay, and then let's go to the introduction to statistics. Okay, so the first one is the variables. Okay, in maths, a variable is a quantity that can take on different values. It is quantity that varies. Okay, in an independent variable, sometimes called an experimental or predictor variable that is being manipulated in an experiment in order to observe the effect on a dependent variable, sometimes called an outcome variable. It can have a few names. Okay, so the important thing is there is the independent and also the dependent. Okay, so this is, for example, okay, the dependent variable, for example, the task mark, the independent variables, the time, okay, of like the pre-test and post-test, for example. Okay, the independent variables is the time. It means that we will collect the same use the same instrument, but we collect in different time, for example. So it's before and after, or before, middle, and after, or before, after, and after that. We can do that. Okay, so that's how we we manipulate the independent variables. All right. Okay, so for in a statistic, when we collect data, this is related to the data. The data, okay, we will get either discrete or continuous variables. Okay, so discrete variables is no value can exist between two neighboring categories. While continuous variables, okay, there are infinite number of possible values that fall between any two observed value. Okay, let's say when we collect quantitative data, for example, we collect data from a survey and then we use the Likert scale. When we use the Likert scale, our data will be like strongly agree, agree, disagree, and strongly disagree. So let's say we have 4 points. Okay. In the survey, we mentioned that there is 4 options to choose. But in SPSS, we will put it into 1, 2, 3, 4. Therefore, there is nobody, no respondent can answer in the middle. It means that nobody can answer like 1.5 or 2.3 or 3.7. No, nobody can answer that because they can only choose between 4 options. Option 1, option 2, option 3, option 4. Strongly agree, agree, disagree, and strongly disagree, for example. Okay, so since there is no value exists between 1 and 2, it's not possible for respondent to choose 1.3, for example. So it called discrete variables. Okay, another example is about, for example, the colors. Okay, we have blue, red, yellow, green. Okay, we cannot say that between green and blue there is something. We can name a color between it, but we can like specifically like the color in the middle. We cannot say that a specific name for that. Okay, so no value can exist between 2 categories is called discrete variables. Okay, I hope everyone clear on this. Okay, is it clear? Anyone? Maybe you can like give me like
Yes,
thumbs up or
madam.
anything to show that you are
Yes.
clear. Okay,
Yes, Prof.
all right, good.
We are clear.
Okay, so that's the first one. Okay, same goes like the grades. Okay, the scores. Okay, when we collect data for the examination, for example, the examination marks, we will have like 0 until 100%. It means that 0 means that no correct answer at all. 100% means there is all correct answer. Okay, all answers are correct. Okay, it means like that. So we can have like maybe 0.1, 0.2, maybe 1.5, 1.6, depends on how we give the marks. Okay, for that kind of marks, we call it the continuous variable. So it can be continued. Okay, however, if the marks is graded, for example, it's become A, B, C, D. So there is no value between A and B. If we say that we want to categorize student, we want to grade student into A, B, C, D. Their score into A, B, C, D. So there will be no one get the score in the middle, A and B. So there is nobody that get half A, half B. No, we never say that. Maybe quarter of A and 3/4 of B. No, we cannot say that. So when it is changed into categories, become A, B, C, D, it has become the discrete. It means that even though that earlier there are continuous variables, but they can be changed to discrete variables. So your analysis will depend on the final measurement. If you say that you want to study their grades, so the grades will be the variables of your research. So you must, when you do the analysis, depend on your variables. Okay, not the one that you collect at the first collection. Okay, so if you change it into grades, so it has become the discrete variables. So you need to remember that. All right. Okay, next. Okay, this is types of discrete variables. Okay, first one, there are two types of discrete variables. The first one, nominal. Nominal, just like its name, names. We name it blue, green, yellow. That's for colors. Or the country, Malaysia, India, Singapore, China. Okay, so we cannot sort it. Okay, we cannot say that Malaysia is better than Singapore and other country. We cannot sort it. So that's the nominal. We cannot sort and we just name it. So that's the nominal variables, or name, the name of the housing area. Okay, so for example, for this example, categories of houses. So there is the condos, the co-ops, the bungalows, or anything. So we cannot arrange them or sort them. So that's, we just name it. Oh, what is your the type of your house? That's bungalow, for example. So just name it. So it is the nominal variables. It is one of discrete variable. Okay, another one is ordinal. Ordinal, the ordinal is another one. This is the ordinal. Okay, the ordinal variables means that we can order them, but it's still discrete. For example, like the Likert scale. Okay, for that Likert scale, okay, there is no values in between. So it's discrete variables and it is ordinal because we ordered them become 1, 2, 3, 4 to say that maybe 1 is the lowest and then second is higher than that, and then third is higher than the number 2, and then 4 is higher than number 3. Or even the grades. A is better than B, B is better than C. So we can order them, rank them. So it become ordinal, but still discrete variables. Okay, and we have another one which is dichotomous variables. It's also under the discrete variables. Okay, some this dichotomous variable actually one of the nominal variables. It can be considered as nominal, or you can call it dichotomous. We just name it, but it has only two options. Okay, di means two. So dichotomous means two options only. So for example, the choice is only male or female. Okay, yes or no, or maybe something else. You like one or two. So only two options. When two options, it called dichotomous. Okay, so that's one. Okay, and then we have, okay, interval variables. Okay, sorry, this one is incorrect. This interval variables is actually continuous variable because of I changed the template actually, so I forgot to change the title. But this is the continuous variables, all right? You need to correct it yourself, okay? Interval variables is continuous variables, okay? For continuous variables, we have two. The first one is interval, the second one is ratio. Okay, this is interval and this is the ratio. Okay, so what are the difference? Both are continuous variables. Okay, so for continuous variable, there is ratio, there is interval. For ratio, 0 means 0. Okay, remember that. 0 means 0. It means that, for example, like scores, okay, marks for examination. 0 means there is no correct answer. Nothing, 0. No correct answer at all. Or for distance, for example, distance, 0 means you didn't move. So 0. No movement yet. Okay. Or if weight, 0 means maybe you are not born yet. That's why. Or nothing is placed in the weighing machine. So 0. 0 means 0. Absolute 0. That's ratio. Okay. But for interval, It is also continuous variable, okay, but the zero has meaning, or we call it arbitrary, okay? We call it arbitrary for interval, okay? It means that the zero has meaning. For example, like in temperature, okay? Zero in temperature in degrees Celsius. We cannot say that no temperature at all. What can you say about 0 degrees Celsius? Anyone can answer me? What does it mean by 0 degrees Celsius? Or you can type if you feel shy. No, it's not ratio. What does it mean by 0 in degrees Celsius? 0 degrees Celsius. Very cool. Freezing. Yes, that the freezing point. Yes, true. Takat beku, correct. So that's freezing point. So it doesn't mean that no temperature. Yes, there is temperature. 0 has temperature, but it is freezing point, or in Malay is takat beku. Okay, so it means that the 0 has meaning. Okay, so if the 0 has meaning, it become interval. Okay, or in IQ test. Okay, IQ test no 0 value, because no one in this world has no IQ at all. At least there is a little IQ. Nobody in this world with 0 IQ. So IQ test is not possible to have 0. We cannot say that 0 is, it's not like, not it's not logic to have 0 IQ. That's why for IQ test, it is interval variable. Okay, so you need to remember that. Okay, if 0 has meaning or 0 is not possible to be there, it's become interval. All right, while ratio means 0 is 0. Okay, so normally exam marks is 0. And normally for research, we will use either exam mark or rubric. Okay, remember, if you use rubric, okay, rubric has the, when you mark, for example, when 1 means, you will give mark like 1, 2, 3, 4, 5. 1 means something with descriptive rubric. 1 means what, 2 means what, 3 means what, 4 means what. Okay, so rubric also ordinal data. Ordinal data mean discrete variable. Okay, however, for scores like examination score, the test that you collect with marks, you correct it. How many answer correct? How many answer is wrong? You count it. Okay, and then you get marks. That's ratio data. Okay, that's continuous variable. Okay, you need to remember that. Okay, ambiguities in classifying type. This is what I mentioned. Okay, in some cases, Likert scale, okay, supposed to be nominal. Okay, however, some school of thought will think that if the Likert scale contains 7 or more value, it become continuous, because so much, it's like so many, you see, 1, 2, 3, 4, 5, 6, 7, or maybe 8, or maybe 9, or maybe they will put the line and then you point it. I want to choose this from disagree to agree. So there is line and then you put the point. I choose this. Okay, it can become continuous for the certain school of thought. Okay, but normally for Likert scale, we consider it as ordinal, which is the discrete data. Okay. Okay, so it's like what I mentioned, but and also some school of thought will think that Likert scale is continuous variable, even have the 5 values. They said that Likert scale is continuous variable. Okay, but you run the SPSS. When you run the statistical test, you are supposed to follow the statistician thought, not the behavioral science thought. It's supposed to be that way, right? Okay, so when you use the statistical test, you're supposed to follow the statistician thought, where the statistician said that Likert scale supposed to be discrete. Okay, as I mentioned before, this title is incorrect if someone asks. Okay, I mentioned before that for this interval, this is supposed to be continuous. Okay, this is the title is wrong. Okay, this is continuous. And another one for ratio also continuous. Okay, my title is wrong. Okay, sorry about that. Okay. Okay, so this is the summary. Okay, so if it is alphanumeric, okay, this is the discrete data. Okay, left side is discrete data. If it is ordered, it is ordinal. If it is not ordered, it is nominal. Okay, about the numeric, of course, the continuous. Okay, continuous data must be numeric. Okay, because there is the points. Okay, decimal points. Okay, so look at the 0. If it has true 0, it is ratio. If it is arbitrary or has meaning, it is interval. All right. Okay, and then go to the central tendency. Okay, this is not yet into SPSS, but it is very, very important. Okay, so, okay. So central tendency consists of mode, mean, median, and mean. Okay, so for the mode is the most frequencies. Mode is suitable for all scale. Nominal, ordinal, interval, and ratio. Okay, let me remind again. Nominal and ordinal are discrete variables. Interval and ratio are continuous variables. Okay, because mode is the most frequency, we just count who has the highest frequency. Let's say when we choose the countries, okay, which country has the highest student in UTM, for example. So the most frequencies, that's all. So all scale can have mode. This is important when you analyze, when you want to interpret your data. Okay, not all data can have all central tendency. Okay, for the median is midpoint. In order to have the midpoint, you must order them from the lowest to the highest. If you cannot arrange them or not rank them or not sort them, you cannot have the midpoint. Okay, so the median is the midpoint. You need to arrange them from lowest to highest or highest to lowest first. So the one in the middle is the midpoint. Okay, therefore nominal scale cannot have midpoint, but because you cannot arrange. Okay, so you cannot arrange nominal because it's just, for example, colors, blue, green, yellow. How you want to arrange? Cannot. You cannot arrange them. You cannot say that blue is better than red, red is better than green, so you want to arrange them. No. Even if you arrange them based on the alphabetical order, still it doesn't it cannot be considered as you arrange them from the lowest to highest. No. Okay, so the nominal scale cannot have midpoint, so cannot have median. Okay, and lastly, the mean. This is one you need to remember. Okay, I know that most of the students with Likert scale doing survey have the Likert scale suddenly have mean. Okay, your data is 1, 2, 3, 4, 5. Suddenly your mean is 3.7. What can you say about it? Between that neutral and strongly and agree, for example. It's not possible to have the value in the middle actually. Okay, because the mean is, normally when we count the mean, the data will be in decimal points. Okay, so it means that the data must be continuous variables, which are interval and ratio only. So the mean is the balance point, the average. So the average is only possible, suitable for interval and ratio scales. All right. So are you clear until now? All good? Clear until the central tendency? Okay. If you have any question, you can just stop me and ask. No worries. Okay. Okay, so that's the previously is the central tendency. It's now on the variability. Okay, variability consists of the range. Range means the total distance covered. Okay, total distance covered by the distribution. It means that the range is you can like minus the highest score and the minus score. Okay, so that's the range. Okay, while the interquartile range mean, okay, for example, this is the normality graph. The normality graph is the bell-shaped graph. Okay, let's say this is the population, is your population or sample. Okay, so this is the normal curve. It's to show that your population or your sample is normal, normally distributed. Okay, the middle one, okay, so this is the median. Okay, or you can say here is the median, this is also the mean, this is also the mode. For normal graph, mode, median, and mean is in the at the center here. Okay, or we can also call Q2. This Q2. Q2 is quartile. Q is quartile. Okay, quartile 2. So in a population, in the whole population here, total is 100%. It means that this under the graph is 100%. Okay, 100%. Quarter is 1/4 or 25%. Okay, so 25% is quarter 1. Plus another 25%. 25 plus 25 is 50%. 50% is half. So half is Q2. Plus another 25, 70% or 3/4. We call 3/4 or also called as 3/4 is Q3, quartile 3 or 3/4. And then the whole, lastly here is Q4. It means that fourth quartile or whole. Consider the whole population because it starts from the left. So this is quarter, half. The total from here to here is half. And from here to here is 3/4. And the whole from here to here is 100% or the whole population. So when you get the value in quartile 1 and quartile 3, okay, for example, you from the SPSS, you can get the score in quartile 1 and also the score in quartile 3. When you did minus it, the score in quartile 3 minus the score in quartile 1, it is called interquartile range. Okay, and then the standard deviation. Okay, and then the variance. The variance is just the square of this standard deviation. All right. Okay, so in research, in quantitative task, normality test is important. Okay, when we want to run the task, okay, so if the variable is discrete variable, okay, if it is discrete variable, either ordinal or nominal, no need for normality test because there is no values between two categories. Of course, it's not normal. You cannot draw this shape because the discrete variable cannot be continuous like this. You will have like value, no value, value, no value, value, no value, value, no value. So you cannot draw the bell shape at all. That's why no need to run the normality test. Even though that SPSS will get the normality test value, but it is not valid. Okay, so for discrete data, which are ordinal and nominal, no need to run the normality test. Okay, for the continuous data, which are the ratio and interval, in order to run the parametric test, need to run the normality test first. Need to check it. All right. Okay, so this is the central limit theory. In the central limit theory, the shape of sample means distribution tends to be normal and guaranteed to be normal if the population is normally distributed. Okay, so this one need to check using the normality test. The population is normal or not. Okay, because if we get the data from not normal population, so it possible is of course the sample is not normal also. Okay, so and then another requirement is the sample size must be greater or equal to 30. So if your data is less than 30, if you refer to the central limit theorem, for example, you collect data and your respondent only 27, it's not enough. So when it is not enough, we can say that it is violate the central limit theorem. So no need to run the normality test and you cannot use the parametric test. So the requirement by this theorem, okay, you must ensure that your sample size is at least 30. And then you run the normality test. If it is normal, then you can use the parametric test. If not normal, you need to run the non-parametric test. Okay, until now, is it clear or do you have any question? All good until now? Okay, because this is statistic, I'm teaching statistics. So much I want to share with you, but we only have 1 hour. So I'll try to make it fast, okay? But later you can refer to the PowerPoint. Okay, so we use the normality test, the Shapiro-Wilk test, if the sample is less than 50. However, if the sample is greater than 50, we still can use Shapiro-Wilk. No worries about that. Okay. However, if the sample is less than 50, the Kolmogorov-Smirnov test is, we can consider that not suitable to use this test if our sample is less than 50. It is only suitable if your sample is greater or equal to 50. However, how many sample you have, it doesn't matter. Shapiro weight, you can still use Shapiro weight. Less 50 or greater than 50 is still okay. All right. So this is how to run. I like to refer to this LA8 website because it's very clear. I will show you later, but later for you to, if you forget how, you can always refer to this LA8. Okay. And then about the skewness. Okay, in SPSS, you can get this skewness data. Okay, you can refer the skewness or you can just use this Shapiro weight test. Both is possible, but no need to use both. Okay, okay, question, less than 50. Less than 50 sample for each group. Okay, so let's say you have this one for each, for samples for Shapiro weight, yes, for each group. Okay, so let's say you have 60 students. However, each of it is 30 is another one group, 30 is another group. It is actually not enough to use this Kolmogorov. It's like just 30 because different group. Okay, so that's how we count it. Okay, after it's in the small group, not the total one. Okay. So this skewness, all right, if it's, you can choose either want to use the Shapirowick or you can use this skewness. Okay, no need to have both in your thesis, but you can refer the skewness to check, to double check about this skewness. It means that, like I showed you before, the bell shape, the skewed shape, it means that it's not really bell shape. Maybe it's skewed to the right or skewed to the left. Okay, the peak is on the left or the peak is on the right. It's not in the middle. That's skewed. Okay. So from here, you can see that if the value is greater than, it's actually the range is from -1 until +1. It means that maybe -0.8 or +0.7. Okay, so the range is -1 until +1. So it can be considered normal, accepted by most of researchers. Okay, that's skewness. See? This is skewed to the left or skewed to the right, something like this. Okay. So kurtosis, another one is kurtosis. The value also we considered from -1 until +1, the same like skewness. So it's very easy to remember. From the range is between -1 until +1, can be considered normal. Kurtosis is like this. It's supposed to be like the green one, okay, but maybe it's too fat or too thin. This is leptokurtic, okay, mesokurtic is the normal one, and platykurtic, okay. So this is the kurtosis, supposed to be the normal shape, but maybe it's too fat or too thin. Even it is not good, so it's not normal, okay. So that's the normality test. Okay. And then the hypothesis testing. Okay. So hypothesis testing is used to evaluate the result from research study. The sample is selected from the population. Treatment is administered to the sample. After treatment, the individuals in the sample are measured. All right. So this is just for example. Okay. This is before, or we call it pre-test. And then we give them treatment and then post-test. Okay, pre-test, treatment, post-test. We hope that they will change to better result. Okay. So, if the individuals in the sample noticeably different from the individuals in the original, we have evidence that the treatment has an effect. Okay. However, of course, there will be simply sampling error. Okay. Maybe, for example, the sampling error can be happen because of the sampling. For example, like our population is all students in UTM. Okay, let's say I'm collecting only 10 students in UTM. I will get a sample of it. But another people will get another sample. Maybe one of mine is there, is hers, okay, and the rest is different sample. So it can be the sampling error because of different sampling we get it, and also different sampling technique. Maybe I get it randomly, but my friends get it using different sampling technique. Purposive sampling, convenience sampling, snowball. So it will have the sampling error. Okay. So the purpose, okay, to the difference between the sample can be explained by sampling error. Okay, the difference between the sample and population is too large to be explained by. It can be so many description about this. All right. So look at here. This is the normal curve. Okay, you know that we refer to the 0.5, right? From here, maybe this is clearer. Okay, our alpha for statistic is 0.05. How we get that? It is actually from this. Okay, this is the Z value. So here is Z is 1.96. Here is negative 1.96. Middle is 0. Okay, so it means that if 0.05, it means it is 5%. Make it into percentage. So it is 5%. It means that here is 2.5%. Here is 2.5%. And here is 2.5% also. Maybe see. Cannot see the pointer. This again. Okay. Okay, so here the value under the graph here is 2.5%, and here is 2.5%. 2.5 on the right plus 2.5 on the left, it will yield to 5%. So this is the value that we refer to. It means that if the value is fall here in that significant difference area, in this significant area, it means that there is significant difference between the with the population. It means like that. That's why if it is less than 0.05, either on the right or fall on the left, okay, there is a significant difference. That's how we find out about that. Okay, so normally for this one, for alpha 0.001 is like 0.1%. Normally we use in medical, or even 100%. Okay, so it is used in medics. Okay, because for medic we cannot afford the error, so must be like no error at all, or very slight error. Okay, that's why. But in behavioral science, okay, or social science, we refer to alpha 0.05 or 5%. Okay, the cut point is here. Okay, so this is how we yield that alpha 0.005. All right. Okay. So the how to do the hypothesis testing. Okay. To do the hypothesis testing, of course, the first one need to state the hypothesis. So you must have null hypothesis, alternative hypothesis in your thesis. Okay, then the next one, identify the significance level. Of course, yours I mentioned before, your alpha is 0.05. Okay, so and then run the statistical test. Okay, how? Okay, so the first one, this is very important, especially in your chapter 4 or 5. When you get the data, identify the measurement scale first. If ratio or interval, check normality. If normal, parametric test. If not normal, non-parametric test. However, if your data is ordinal or nominal, directly proceed to non-parametric test. Okay, this one this very important. Okay, and lastly, of course, you need to interpret the result. Okay, you will get the significant value from the SPSS. The P value is the significant value. And then need to compare with the significant level, which is the alpha value 0.05. Okay, if the significant value less than 0.05, reject the null hypothesis. If the significant value greater than 0.05, it means that fail to reject the null hypothesis. In statistics, we didn't say accept. We didn't say that I accept the null hypothesis. No. We say that we fail to reject the null hypothesis. It is actually means that we accept, but we twist the word. Fail to reject. We cannot reject the null hypothesis because the significant value is greater than 0.05. So the null hypothesis is accepted actually. It means that no significant difference. Okay. So it is like that. This is the sample of null hypothesis. Null hypothesis means there is no difference or equal. We can say equal, no difference. Okay. While the alternative hypothesis, we say that not equal to, there is a significant difference, there is a significant relationship, for example, like that. All right, that's the alternative hypothesis. This is the errors. Okay, we have the type 1 and type 2 errors. Okay, basically this is for you, for easy for you to understand maybe. Okay, type 1 error, false positive. You are pregnant, sit to the man. Of course, okay. And then type 2 error is false negative. She is pregnant, but doctor says you are not pregnant. So this is some errors related to it. False positive, false negative. All right. So this is the normal curve. For example, this is the before pre-test. Let's say the pre-test, this is the normal curve. After the treatment, maybe there is the movement, because if the marks is increasing, so the shape is increased to will move to the right. If they are all student has decreased in marks, so the shape will move to the left, something like that. Okay, this is just to show the graph. Okay, and then the statistical test. All right. Okay, so the statistical test. How to write results and finding synthesis. Okay, this is I just give this 7 steps to do that. Okay, first one, restate the research questions. Okay, I'll show this later. Restate the research question. When you are writing in your chapter 4 or 5, depends on your chapter. Some students have 6 chapters, so the result in chapter 5. If student with 5 total chapters, the result in chapter 4. Okay, so the first one, you need to restate the research question to remind the readers that, okay, the first result and finding is about this research question. Okay, and then describe the data collection method. How, in order to answer this research question, how you get the data. You can say that from, for example, from the test, how the test is collected before the treatment and after the treatment. So you have two period of data collection. It means that before and after. So from that explanation, the reader will understand, okay, you have 2 data and you collected before and after. You need to mention in chapter 4 or 5. All right. And then what you need to do, present the raw data. You said just now you have the pre-test and post-test. So show it in a table. Okay, these are my respondent. I have 30 respondents. Don't put the name, just put respondent or student A, B, C, D, E, F, G, H, I. Okay, just name it whatever, however you want to name them. Okay, represent them with this the ID. Okay, maybe ID1, ID2, ID3 is up to you. Okay, as long as we can see that, okay, just now you said that you collect data twice. So you will have the respondents or the students, and then these are, and then you put in the table, these are their pre-test score, and then these are their post-test score. You must have that table. Okay, and then from that, after you present the data, you mention that, okay, this data, for example, is ratio scale. Therefore, you can say that, therefore, parametric, we can run the parametric test. However, the first one that we need to do is identify whether it's normal or not. We need to run the normality test first. Okay, so you run the normality test. If it is normal, and then you run the parametric test. If it is normal, then no need. You need to run the non-parametric test. Okay, so and then follow the hypothesis testing procedure, that 4 procedure. First, state the hypothesis. Second, identify the significant level, which is 0.05. Of course, you knew it already. The third one, run the test. The fourth one is interpret the results. That's the 4 steps that I mentioned before. Okay, previously. Okay, so this is what to do. Okay, how to do this? Let me show you. Okay, this is just example. This is actually the assignment in my ODL class, but I will like give them exercise to write it. Okay, so it start with, okay, for example, this discussion, okay, this topic will address the research question. What is it? Mention that the research question. Okay, this question requires analysis of what? From which instrument? Which data that you collect once? Okay, once or twice. Let's say this is for pre-test and post-test. This is that I mentioned before. You must show the raw data first. Okay, this is to write in the thesis. Show raw data first. Okay, and then, okay, mention that, okay, this data, okay, what is the dependent variables? Okay, and then both the variables contain what data? For my example, both is ratio data, pretest, post-test, examination score, okay, ratio data. So advised to perform parametric test. Okay, however, the first requirement is to run the normality test first. Okay, so this is the null hypothesis and alternative hypothesis for normality test. It's not yet to the test. Okay, normality test first. Okay, and then I get this using the Shapiro work. Okay, and then I get this value. Okay, so if this significant value is greater than 0.05, it means that the data is normally distributed. How to find out? Okay, look at this null hypothesis and alternative hypothesis. For normality test, the null hypothesis is normally distributed. It means that normal is the null hypothesis, no difference. That I mentioned before. Normal equal no difference in the null hypothesis. So null hypothesis is normally distributed. Alternative hypothesis is not normally, is distributed. Okay, remember that I told you that we refer to alpha 0.05. Okay, to make it easy for you, okay, how to write. Okay, so here from this, okay, the cut line is the 0.05. Okay, let me find out how to write here. What is I? Okay, the cut line is here. Okay, so 0.05. The cut line is in the middle between A and B. Okay, so if you get greater than 0.05, greater means above. Greater is above. So when you get 0.05, if you get greater than 0.05, look at the above one. The one above is normally distributed, right? Okay, so if you get less than 0.05, it means that look at the one below. So it means that not normally distributed. That's how to remember. So same goes to the rest. You need to write the null hypothesis and alternative hypothesis first. So easy for you to identify which one to read. Okay, so from here, I get less than 0.05. So I need to read the below part. It means not normal. So my pre-test is not normal. My post-test is not normal. Therefore, I cannot run the parametric test. In order to run parametric test, both, if I compare both must be normal. If I want to compare 3 groups, all 3 groups must be normal. If one not normal, still cannot run the parametric test. Okay, so for me, because I found out that it's not normal, I need to run the non-parametric test, and then I need another hypothesis for the test. The previous one is the hypothesis for normality test, but this is the hypothesis for the statistical test. Okay. For the non-parametric test, this is the hypothesis, and then I got all the results and discuss. Okay, so I hope this is clear. All right, so this is just for example of the objectives and statistical analysis. This is not available in your PDF. All right, so this is just to show you. Okay, this is example of objective to investigate the difference in student statistic achievement based on gender. For example, see, I want to study the difference in achievement between gender. So gender, for example, there is male and female. So 2 independent groups. Okay, and this achievement is because examination scores, so continuous variables. Okay, and number 2, different races. Okay, so more than 2 independent groups. Okay, the third one, to assess the effect. See, when I say about the effect, there is the treatment. So the effect of my learning strategies, this is for example, my teaching strategies on student achievement. So it can be there is the pre-test and post-test, or pre-test, post-test, and another post-test. Okay. The fourth one, to study the relationship between 2 continuous variables. Okay. And then to investigate student preferences in online learning tools. This is using the chi-square test. Okay, because preferences in online learning tools. For example, the online learning tools, whether I like to use Moodle or Kahoot or Quizzes, so that's the nominal data. Okay, so these two using the chi-square test, while the last one to predict whether, for example, if I get the CGPA value, I can predict the achievement. For prediction, this one is regression. Okay? So that's how. So you can refer to all to compare. For example, there is the parametric test and non-parametric test. Okay, how to do that? You can refer to my guidelines here. Okay, you can refer to all my guidelines. All right, all guidelines are available in that PDF. Okay, so I want to show you some, just a few on the SPSS. You still have time with me? Is it
Yes.
okay? Okay, so for the rest, if you have any program, okay, the recording will be shared later. Okay, no worries. Okay, now this is SPSS. You can
Now,
get it. Yes.
but there's no link for attendance.
Attendance. All right, because I didn't get it, the attendance. Wait for a while. I didn't get it from. Okay, it's okay. So for attendance purpose, because they didn't give me anything, can you please send email to me? Okay, wait, before you signing in, okay, so please fill in the email to me, okay, let me share my email address. This is my email address, norazrena@utm.my. Please share your name, full name, and your metric number. Okay, so I will consider that your attendance, and I'll share that to my colleague for the certificate purpose. All right. So this is the SPSS. You can download it from UTM Software Center, but maybe not today because I think the UTM system is quite down this week and last week. So please hold on for that. Okay, however, if you have the SPSS, you can use it. Okay, this is my example of data view. Okay, let's say this is based on the objective that I shared before. This is my pre-test, post-test, post-test. This is the gender where, okay, one is female, okay, one is male, two is female. Okay, oh, Hidayah shared it. Okay, thank you. So, and then we have another one. Okay, so for one is that's race, one is for Malay, two is for Chinese, and three for Indian. This is just for example. Well, this is the online tool, for example. Okay, so one is for Google Classroom, two for the e-learning, three for the ODL system. Okay, this is just dummy data just to show you. Okay, so this is the analyze area. Okay, so remember, the first thing in statistic, you must know the measurement scales, with whether it is discrete or continuous. That's very important. Okay, so here. So if it is nominal, then it is nominal. If it's ordinal, it is ordinal. But scale means continuous data. If the ratio or interval is considered scale. Okay, so here, first one, you need to know this measurement scale. Okay, if the data is discrete data, okay, no need to run the normality test. Okay, so if it is the continuous data, you need to run the normality test first. Where to run it? Okay, here. To run it, it is in this explore. Explore. Very easy. So when it is the continuous data, either ratio or interval, first thing first is explore. Explore first. Okay, of course, this is my pre-test. Yes, is ratio. Post-test ratio. Post-test also ratio. The rest, okay, CGPA is ratio. Okay, the rest is not. Okay, the rest is not. So only I can only run the normality test on these 4. Run here, and this another one. Okay, so this statistics, okay, this is continue. Okay, and then plots, normality plot with test is important. Okay, welcome for those who want to leave, welcome. And then continue because maybe you have class, right? Okay, this is no need. So the important one is here, normality plots with test. And then, okay. Okay, and then you will get this output view. Okay, so look at, as I mentioned before, you will get this skewness and kurtosis. You can look at here. If it is greater than the range is -1 until 1, it is normal. So this skewness for this one is normal. This one is also normal. But for my second one is greater than 1. So not normal. This one also not normal. And then this one is less than 1. So it's normal. And based on this kurtosis is also normal. Okay. And then this one is normal and then normal. But we need to double check it with this Shapiro weight. When you run the normality test, you will get both Kolmogorov and Shapiro weight. Okay, as I show you before, when you copy and paste this table in your Word or document, you need to remove this Kolmogorov because you need to take only Shapiro. No need for the Kolmogorov because mine even 35 is not enough. So it's not really relevant to use this Kolmogorov. So I use the Shapiro-Wilk. Okay, remember for the normality, I want to make sure that the significant value is greater than 0.05. So the first one is normal. Second is not. Third is normal. The fourth is normal. So it's correct as I mentioned before. This is not normal. The second one, not normal. So it's valid. It's true that the second one is not normal. Okay, this is the general. However, remember that. However, if you want to run the analysis and then you want to compare between two groups, okay, you want to compare between two groups. Okay, let's say this descriptive statistic. Okay, I want to compare the first, maybe the post test, but I want to compare between gender. I cannot use that normality test. Cannot, it's wrong. Because if I say that I want to compare between gender, I must factor them into gender first. See, factor list gender. If I want to compare based on race, I need to factor list factored by race first. That's how we do that. So let's say I start with gender first and then okay. See, I will get for this post test achievement 3, it factored into male and female. Okay, look at here. The male is normal. Female is almost not normal, but still normal. So it's okay. Still greater than 0.05. So both normal, and then I can compare score between male and female. If not, this normality test is not valid. If I did just like before previously, not factored them between groups, it's not valid to run this test. I mean that not valid to run the, to compare means between two groups. It's not valid. If I want to compare between male and female, I must run the normality test between male and female first in terms of their scores. Okay? Need to remember this. You cannot make it general and then you just say that it is not normal. No, it's incorrect. Okay? I hope this is clear. Okay? Can you give me at least thumbs up to know that you are clear? All right. Okay, so that's the normality test. Okay, need to remember that. And then where to run? Okay, here I just showed these are the parametric tests. Independency, this independent sample t test. It means that t means 2. T test is compared two groups. Independent sample t test means that two groups are independent, like male, female, or class A and class B, or Malaysian and Indian. It means that Indian from the India, okay? Or what, Malay and Chinese, two independent groups, okay? So to compare that two independent groups, you need to use this if normal, remember? If normal and continuous data. Okay, if more than two groups, let's say three groups like the race, Malay, Chinese, Indian, three independent groups, or Malay, Chinese, Indian, others, or Malay, Chinese, Indian, kadazan. Okay, so four, need to use one-way ANOVA. Here. Okay, it's here for two independent sample test, for two, more than two, one-way ANOVA. Okay, and then see, this is t-test, means two, but paired. If paired means one group is tested twice. It means that only one group, I have one class, okay, I have one class, Master Educational Technology class, and then I want to compare their pre-test and post-test. I give a pre-test and then I give them treatment for 1 month, and then I give the same people answer and the same question before at the end. So pre-test, post-test. That paired t-test, paired sample t-test. I assess them twice, before and after. That paired t-test. Pairing. So paired, before, after. Pairing. If I give them more than twice, it means that I give them before, during, after. So it's 3. So I need to run, it's here. Repeated measures ANOVA here. More than 2. Okay, maybe thrice, or maybe I give them pre-test, treatment, post-test, and then I give them another 1 month and give them another post-test, post-test. I want to see when on their retention, are they still remember what I taught before? So that's also considered. Okay, what is ANCOVA? Okay, ANCOVA is like this actually. You want to compare, okay, because these repeated measures, you just compare first, second, and third. Okay, this ANCOVA, you actually want to compare different group. Okay, repeated measures is same group. It means that you give them 3 tasks to same group. Okay, but we have another here is ANOVA. Okay, this ANOVA, 3 different groups. For example, class A, class B, and class C. Okay, but for this ANCOVA, it can be 2 groups actually. It's possible to have 2 groups, but you want to compare their, okay, it's like this. It's okay, sorry. It's difficult for me to explain. Normally, when we compare the one-way ANOVA in 3 groups, we will use their post-test, right? Post-test for the first group, post-test for the second group, post-test for the third group. Is it correct? The same test, but 2 different groups.
Yes, correct.
Okay, so 1 test only. However, ANCOVA is 2 tests. It means that I give these 3 groups pre and post. Okay, so I have the first group pre and post, so it's 2 tests. Second group also pre and post. The third group also pre and post. So that's why I use ANCOVA to see whether that pre-test or post-test affected each other or that in that comparison. Understand? So it's different. That one way ANOVA only one test, but that ANCOVA we have two tests, pre and post together towards different group.
So, Doctor,
Mm.
I'm Hidayah. I would like to ask if I'm doing experimental. So, I'm gonna do pre-test and also post-test. So I have to do uncover. Am I right?
If you have
To
two groups, for
if
example, control and experimental group.
I see, whereby the ANOVA is only one group, meaning that we don't carry out any post-test. We just do one test. Sorry, I'm not clear about that.
Okay, it's like this. Okay, one way ANOVA, you give them, yes, you can give them pre-test and post-test, but when you do the analysis, you just want to compare their post-test.
I see. Okay.
But for ANCOVA, you want to see the improvement in post-test, but you want to see whether the pre-test also have the effect or not.
Doctor,
Yes?
I want to be clear about the ANCOVA. I'm the one who asked about the ANCOVA.
Oh, yes.
Okay, okay. My research is I'm doing the experimental group and the control group. Okay, so one group will be have the treatment, and the other group will have will proceed with the basic one. Okay, so I prefer to do the ANCOVA because, as you mentioned, with the analysis is based on two groups, and is based on actually one group with the treatment and another group is the
Without treatment.
without treatment. Is that right? Is that right, Doctor?
Yes, it's
So I
correct.
apply on the ANCOVA. So
Yes.
but the writing I also must discuss about the dependent variable or the right?
True.
Okay. All right. Thank you, Doctor.
Okay, so it's better because nowadays, because sometimes the researcher just because ANCOVA is sometimes quite difficult to interpret. So they prefer to just compare the post-test between two groups, the control and the experimental group. Or they just like calculate the difference. For example, they have the post-test, they have the pre-test. They just calculate the difference between post-test and pre-test and then they compare. So that one just use for if two groups just use the independent sample t-test. It's easy. But it's very good if for you to when you have the control group and experimental group, you use the ANCOVA.
The test for the normality and all the size is also can also need to be
Yes, needed.
needed. All right.
So if you found out that one of it is not normal, okay, you cannot run the ANCOVA. Okay, you need to run the, I don't remember the non-parametric test. Is it the this start with Q. The test is start with Q. Okay, you need to run the non-parametric test of ANCOVA. Okay, you cannot run the ANCOVA if it is not normal. Let me find out the name first. I forgot. It start with Q. I just remember it start with Q. Of ANCOVA. I think it's quite test or something. Okay, but you can quit. Sorry, it's quit test. QUADE. Okay, so you need to find out. You can find it somewhere online. Okay, you can find it from the YouTube also how to run it. Okay, quit. Yes, true. Quit test. So that quit test is the non-parametric of ANCOVA. If it is not normal, you must run that. All right. But it's very good.
Okay, one more question, Doctor, about what is actually when I read about this social science research, what is actually assumption of ANCOVA? What is assumption? Why do we need this homogeneity, all this thing, all the terms?
Homogen.
Yes.
Yeah, that's because that the requirement of non-parametric test. Okay, you can refer to my slide. Okay, look at here. Okay, here. For example, in t-test, even in t-test,
Yeah,
we
this
need to
homogeneity of
ensure
variable.
that measurement scales is the continuous variables and it must be normal. And then even though it is normal, if it is the variance is not homogeneous, okay, but in t-test there is the option to choose. Okay, but in non-parametric test, we need to run the it means that there is another test that when we get it, it is not homogeneous, we need to run the non-parametric test. Previous SPSS, no value about it. Okay, let me show. Okay, let me show you. Okay, this is from the SPSS. Sorry, I took longer. If you have time, no worries for that. Okay, let me run. Okay, independent t-test. Let's say I got it is normal. Okay, so I want to run this. This is independent. Okay, so the group is 2. So 1 and 2. So okay. See, I get this. See, this is the equal variance assumed or homogeneous. It's at least Levin test is about the homogeneity or the equality is the same. Okay, even we need to look at this value. It's just like normality. Remember, for normality, we want the value to be greater than 0.05. So here, if the value is greater than 0.05, we will read the first row. If this value less than 0.05, read the second row. Okay? And here there is the Cohen's d point estimate. This is the effect size. This is only if there is the significant difference. Let's say here less than 0.05. So it means that there is an effect. So if there is an effect, you need to find out the effect size. So how big is the effect? Okay, if there is no significant difference like this example, because greater than 0.05, no need to look at here. Okay?
Okay, Doctor. Thank you, Doctor.
All right. So here, okay. So here, that one, okay, I repeat again. Here is independent t-test, PET t-test, one-way ANOVA, and then this one is repeated measures. Okay. And then we have the correlation. We normally use this bivariate because 2 variables bivariate. Okay, under this bivariate, we have both. This is Pearson for parametric test. This is Spearman for non-parametric test. Both available. So if the data is continuous and normal, use Pearson. If the data is continuous but not normal, use Spearman. If the data is discrete, use Spearman. Okay, so this is for correlation. Okay, and then regression, linear regression, only if the data is continuous and normal. Because this one, we want to create a straight line. If the data is discrete, we cannot create a straight line because there is the empty value, empty. So our straight line will like line, empty, so it's not a straight line. So regression, linear regression is only for continuous and normally distributed data. All right. And then we have the non-parametric test here. Okay, so here, this is the chi-square. Okay, and then this is two independent sample, just like in mean just now, we have two independent samples. Independent sample t-test. That's the same, but this one is non-parametric. K independent sample is the non-parametric of one-way ANOVA. Okay. Two related sample is the non-parametric of PET t-test. And this K related samples is the non-parametric of repeated measures ANOVA. Okay. So this is where you can get it. Okay. So because we only have actually 1 hour and I already exceed until 4 now. Okay. So even though our colloquium is finished today, but don't worry, if you have any question related to statistic, you can contact me either through email or you can get my phone number if you need. I think you have my phone number, right? All right. So I think for today, that's all. Okay, thank you for joining me for this colloquium. I hope this sharing helps you in the quantitative analysis. All right. So don't feel shy to ask later, even after this colloquium, because we are from the same department, right? So we can help with each other. Okay. All right. So I think thank you very much to all. Okay, so thank you for listening and hope to see you again. Okay, bye-bye. Assalamualaikum and good afternoon.
Thank you, Doktor.
Welcome.